Hello everyone, this is John from EastCoastArmory.com, and I'm here today with a project update video for this 1/6 scale radio-controlled Armortek Firefly Sherman tank. Since the last video update, a lot of progress has been made to the model's interior as well as its running gear. The tank currently sits in a working format, and the tank will be taken for a test drive, as well as more information will be talked about the accessories and equipment that has been added to the model in order to get it to the condition that you see here. Starting with the motors. The motors that I'll be utilizing on the Armortek Sherman here are these units over here. These units were supplied by Armortek, and I have used them in previous Armortek builds. They are very strong, very powerful, and are more than adequate at propelling the tank. The motors come pre-assembled in the format that you see here. You have the motor, and then you have this CNC aluminum gear housing. The main drive pinion gear is pre-attached by Armortek, which is a nice feature. It is secured on with a single roll pin, and I've never had any issues of these pieces getting loose or falling apart. As for to mount it to the vehicle, that is facilitated by these three bolts here. Again, these bolts are supplied by the Armortek kit. The only addition I made to the bolts is the addition of a lock washer. I like to add lock washers to all these components prior to the installation. Also, as you can see, prior to the installation of this piece, I went ahead and added some more grease to the pinion gear in order to fully make sure everything is nice and thoroughly lubricated. The last thing that will be added to these fasteners here is a smear of red Loctite in order to have the pieces stay on for years to come. And here's one of the motors mounted to the model. As you can see, it's a very tight area to work in, which is why it's important to pre-mount your fasteners to the gearbox housing, as trying to insert those long fasteners in this tight recess is going to be very difficult, if not impossible. Also, as a quick mention, these components here are not pre-threaded. They are simply just holes. The threading is actually on the motor mount itself, which makes for an easier install in that you don't have to put any fasteners on the opposite side of the flange in order to mount on the motor. It's also important to mention that prior to the installation of the motor, it's a good idea to thoroughly vacuum the inside of the model. The reason for that is that you don't want to have any sort of particulate, namely that of metal filings, which can fall inside of the final drive or can get stuck on the pinion gear. In case, as a quick recap, the main motor mount here has paper sealing off the hole. This was done right after the installation of this component. Now that the motor is ready to be installed, I can remove the paper plug, add some Loctite to the fasteners, and proceed with the installation process. And here's the lower hull now ready for its subfloor, which will then lead directly to mounting of the electronics to get the model running. As for the subfloor itself, it is made out of a piece of Lexan plastic. It is reinforced with 2 lengths of aluminum angle that have been bolted through and through with hex fasteners and nuts. All of the fasteners you see here are red Loctite in place to keep them firmly in place. Like I mentioned in the other video, this model here does have a full detailed lower body pan detailing. Because of that, you cannot just simply mount the components directly to the bottom of the pan, as you're going to have to drill through, which will have unsightly fasteners on the bottom, which will hurt the look, specifically of all the detailing that I did. However, one mod that I do on the Shermans is that I like to go ahead and mount everything to a subfloor. Now, typically, like I frequently mention, subfloors are usually done on German tanks due to mount components to the interior that have the crisscrossing torsion bars. You can't just mount them directly to the floor pan. Same concept will apply to the Sherman. This is also the same technique that I did on my own M4A4. As for mounting on the subfloor, as you can see, I have 2 rows of fasteners. These 2 rows here are actually the fasteners which hold on the rigidity bulges, which are on the bottom of the hull, and they run across the lower span. They are bolted to the tank via fasteners. As you can see, I purposely use very long fasteners for the installation of those parts, as they are bolted to the bottom via this nut here, and the same fasteners are going to serve double duty and hold up the subfloor from the bottom of the tank. Now, to mount on the component, on this vehicle here, I went ahead and developed some spacers. The spacers themselves are made out of PVC tubes, which were filled in with resin, and were then all turned on the lathe to give them a uniform height. They were also drilled out with the diameter of the threaded shaft or the fastener, and to compensate for the fastener that's already on the tank, I went ahead and double bored the hole so that once installed onto the piece, the spacer is flush with the floor. Same procedure was done to the rear portion as well. The subfloor has corresponding holes that are drilled into it, and these holes here will simply just line up to the ones on the lower pan, and the whole unit should just slip right on. Once slipped on, I'll go ahead and mount it on with the fasteners, which will secure the subfloor permanently in place. And here goes the equipment tray, with now more components starting to be mounted. Starting from the rear to the front, this here is the rear portion of the tray. Currently it's empty, however, there will soon be equipment mounted here, namely the smoke system and the refueler. In the center portion here, we have here the battery tray. Now, the battery tray itself is a slightly different design compared to my older units. The battery tray, which is found on my older builds that are found on my video listings, utilize a system similar with the use of aluminum angle to create a box. However, their system utilized bungee cords to go ahead and keep the batteries in their place. That system did work. However, with some feedback from customers, I went ahead and redesigned the battery mounting system with that of a nylon strap, which is Velcro, compared to the elastic system. The battery tray here is actually currently missing one piece, and that is of this component here. There are 3 holes, and the piece simply mounts to these 3 holes. The reason why this piece is still loose is because these 3 holes are the 3 mounting holes which are found on the bottom of the hull. Once everything slides into place, this angle here will be fitted, and then fasteners will be mounted, permanently mounting the bottom pan to the Sherman's hull. Moving our way front takes us to the mounts for what will be for the speed controller, as well as the auxiliary power module. On this tank here, I designed a setup that everything will be bolted together in a stack, similar to kind of what you see on PCs type computer circuit boards. This here is the Armortek speed controller system. These systems are very nicely done and are used on all the Armortek builds, and are highly recommended to use them if you're specifically building an Armortek and making it radio controlled. Everything is plug and play, which I frequently mention. As for the mounting, I went ahead and widened the holes for the mounting fasteners so that the pieces now fit onto the system here. As for the system, I have 2 Allen bolts which are threaded directly into the Lexan, and they are Loctite in place to keep them from ever loosening. The way the system works is that the electronic slips onto the component, and then there are 2 custom turned aluminum columns. These columns that you see here, the columns that you see here are custom made. They are made out of turned aluminum. I made them on the lathe, and are tapped with the same threading that's found on the fasteners here. The way they work is the system will be bolted in place and tightened on so everything is affixed nice and securely. With this bolted on, this module here will be permanently mounted and will not wobble or move. The auxiliary module will then rest on top of the columns, and then 2 more Allen bolts will thread into these locations here, which will in turn keep everything nice and mounted. And also it conserves space, as space in these 1/6 scale tanks does get utilized very quickly, specifically once you start adding in electronics and components. Also, one benefit that the columns have is that since the pieces are not directly sitting on top of each other, this allows airflow, which will keep the pieces nice and cool and prevent any overheating, which is something that is very rare to happen, but it's a nice feature to have with the ventilation. With speed control now bolted to the Lexan plate, I will now drop it into its desired location. The holes simply just line up, and the whole system just drops directly into the columns that were mentioned earlier. With those mounted on, now take the aluminum angle, slide that onto the location as well. Now when the time comes to permanently affix everything, I will go ahead and mount on lock washers as well as the appropriate fasteners, and that will keep everything firmly in place. It is at this point here where I could mount in the batteries. Now, as for the batteries, like all Armortek tanks, they are powered by 24 volts. In order to obtain the 24 volts, you need to hook up 2 12-volt batteries in series circuit. Now, in the past, I used to utilize lead-acid batteries. However, one of the drawbacks with lead-acid batteries is that the batteries themselves require a lot of babying in order to keep them from discharging, as well as also to prevent them from getting any sulfication. The lead acids tend to be problematic. However, I have switched over from lead acid to lithium ion. These 2 batteries here are from a company called smartbattery.com. So far, I've utilized and tested these batteries in my Armortek M4A4, and I have nothing but praise for these batteries. Being lithium ion, they are about 70% lighter than the standard lead acid battery, which is great in that it has less wear and tear on the model suspension. The lithium ions are also, one thing that makes these batteries special is that you can charge them with the standard recharger system and setup that I use on my other build. So it's a drop-in. I don't have to have any fancy other rechargers in order to charge up these 2 cells. The batteries that you see here are each 12 volt and 20 amp hour. The comparable lead acid batteries that I used to use were 12 volt, 18 amp hour. So these batteries here are superior in their amperage. The batteries also have a lot longer running time compared to their lead acid counterparts. The batteries that you see here are already wired in series. The jack here is the stock Armortek supplied unit, and the joining wire here was fabricated by myself. I will now go ahead and start mounting everything in a temporary manner in order to test the speed controller as well with the motors and really get the tank up and running. Another design feature to point out is that if we notice, the batteries on this model are mounted in the center of the vehicle. This is a recent feature that I started doing on these Armortek builds. In mounting the batteries in the center does offer several benefits. First, the batteries are in the center weight of the vehicle, which distributes the weight evenly across the tank suspension. Another benefit of having the batteries in the center is that if for whatever reason the batteries need to be exchanged or replaced, you have easy access to the batteries via the turret ring on the top. Another reason to add the batteries in the center is, namely on a Sherman, is due to the dimensions of the hull. With the way the Sherman's hull is designed, where it tapers and tadpoles towards the rear of the vehicle, if the batteries are in a stand-up manner like this, you will have problems mounting them in the rearmost portion of the vehicle. With these lithium ions, you can mount them horizontally and as opposed to vertical with no issues. However, mounting the batteries vertically is just a lot simpler with the strap method. And here's the interior now with the components activated, and the tank currently can drive. Now keep in mind, this layout that you see here is very, very raw and very crude, and this layout here will more than likely change once everything gets finalized and more components and functions start getting added. However, the way you see the tank here is currently in a running state. For the tank's radio, I went ahead and borrowed this Futaba 6-channel radio. This radio here is only being used for testing purposes and will not be the final radio that this tank will receive. Here we have the tank's power supply module. Again, this is all contained with the Armortek motion option pack, and again is highly recommended and works very well. Here we have the system broken down. This cord here is what plugs to your radio and has a BEC, so no external battery is required for your RX. These two wires here are for certain functions, namely the smoke system as well as the turret rotation. These two and this portion here of the power supply is what divvies out and divides the 24 volt and allocates it to its appropriate areas. This version here is what powers the main drive motors, while the other components will be used on other portions of the build, namely the gun elevation and other features as they become online. The motors are hooked up. The way they hook up is from the speed controller. Everything is basically plug and play. Only thing to watch out for is that when you're plugging in the motors, make sure that the plugs are thoroughly plugged and snapped into their appropriate locations in order to prevent any hassles of plugs undoing themselves as the model is driving around. Also, as you can see here, in an effort to keep the interior neat, I went ahead and zip tied the loose wires around the motors in order to keep them firmly in place. This may or may not change as the build progresses. I will now go ahead and test the system by first turning on the radio, which is a good idea to do on any radio control tank. With the radio on, I will now turn on the tank. See, it's got a power light. The RX is powered on. Now, and the opposite side. As for the noise that you hear, that's done by the gear ratio and the Armortek gearbox. And here's the sprockets of the tank now fitted to the model. As for the sprockets themselves, they are all stock Armortek, and the taper brush lock is what's used to keep the sprocket mounted to the center spindle, as is mentioned on all of the Armortek builds. Also, currently that is not seen in this shot is that of a hubcap. The hubcap will be added to the sprocket assembly further down the road as the model progresses. After the sprockets were mounted, it was then time to turn my attention to the track. The track on the tank is the Armortek stock tracks that came with this kit. They represent that of the steel chevron pattern of Sherman tank track. The tracks on the Armortek Sherman kits are very nicely done, as what was mentioned in the M4A4 videos. They are all consisted out of die-cast components, which consist of a track pad, as well as a guide tooth, 2 chrome steel track pins, as well as a CNC'd aluminum lock bar, which is held in place by a small fastener. This design here is very closely matching that of the real Sherman tank in the way those tracks are assembled on the real vehicles. Tracks do a great job in both visually as well as propelling the tank. One thing to keep in mind, though, with these type pattern of tracks is that due to all of the little fasteners which are found on these tracks here, Loctite is extremely recommended to hold everything together. If Loctite is not used, the tracks will unthread themselves, and the whole track will simply disintegrate while the tank is in operation. Needless to say, is way less than ideal. On this tank here, all of the fasteners have been Loctited together. However, I will also, for safety measure, be adding a drop of super glue on each of the fasteners as well. Super glue will give an extra barrier and an extra redundancy to prevent the fasteners from ever getting loose. It's also important to note that on my M4A4 Sherman, that tank has driven for many hours, and the tracks have held up quite well, and I haven't had a single malfunction with the track pins coming apart on themselves. The same can also be said for my Armortek M4A3 Sherman, which features the same track design, and that tank has been running longer than the M4A4, again, without a single issue with the tracks. With the track installed, it is then time to start adjusting the track tension. The track tension on the Armortek kits are just like on a real Sherman tank, and they're adjusted from the rear idler mounts. If we recall from an earlier video, this fastener here holds onto this plate, and this plate is connected to the spindle, which adjusts the motion of the rear idler. This component here has a square cutout, as well as a square notch that's in the CNC steel spindle mount. You can ratchet this plate here to the proper angle in order to attain the track tension, to which then the fastener is tightened. This system does work. The track tension that you see here is somewhat adjusted. However, it's going to be finally more refined when the tank starts going further in its build. When it comes to track tension, a Sherman tank is very, very important. The Sherman tank design itself does require a certain type of track tension. Unlike some other tanks, namely Russian or even German tanks, in which you have a lot more freedom with the tracks, on a Sherman tank, it's not so much. Sherman tank, this track tension needs to be set just right. If the track tension is too tight, you'll be putting a lot of strain and wear on the idler, as well as the sprocket. Also, if there is any type of dirt and debris that enters into the track, it will cause the suspension to skip, which can cause a lot of issues, namely track derailment or some other complications. If the track is too loose, when the tank is driving, you will have a large slop area in this portion here that builds up. With this portion here, the tracks will begin to kink, which will cause a few other problems, namely the tank will jump and possibly throw a track, as the track will get misaligned over the road wheel and the track will be thrown. Again, all these are less than ideal. For the Sherman tank, like I mentioned, you want to have the tension set just right. As for what just right really is, that is something really more for the feel of the builder. Again, you want to have the track that you don't have too much kinking going on the front, but you don't want to have so tight that you have absolutely no play if the track needs to have a little wiggle room. The tank is now ready to go on a test drive. Now, like I mentioned earlier, the electronics layout that you see in the vehicle is really crude at the moment. It is purely set up just for testing purposes, and as the build progresses, will become a little bit more refined. To turn the model on, like with all tanks, first you turn on the radio, and then the power switch. Now, just like with all Armortek tanks, there is a nice audible click when the power is turned on. The vehicle is now on, and we will begin the test drive. As you can see, the tank performed quite well, specifically for an initial test drive. The track tension seems to be set okay. There's definitely enough links on either side, and the rear idlers will have a little bit tweaks made to them in order to have the tank's visual appearance be a little bit better. Also, it's important to note that once the tank starts progressing past this point, the weight will start increasing a little bit due to the turret as well as the top deck and other components which will be added, to which then if any adjustments need to be made to the track tension, they will be made at that point. With the test drive being a complete success, the vehicle will head back to the shop, in which there the other mechanical components, namely the sound system, smoke generator, and turret rotation equipment, will start to have their components fitted and calibrated as well. More information on this is to follow in an upcoming video update. And with that, that concludes this project update video for this 1/6 scale, radio-controlled, British 5 Firefly Sherman tank. If you like this video, stop by and like us on Facebook, and don't forget to check out eastcoastarmory.com for more 1/6 and 1/16 scale builds and detail components. Thank you.